Hello everybody, this video is going to be about nuclear decay series. We're going to learn that not all nuclear reactions happen in one step. Sometimes they go through a series of steps, and we can write those out as an equation, or we can even graph them on a piece of graphing paper. So let's get started. While we often write the starting and ending point for reactions, sometimes that's not going to be the case for a nuclear decay series. Sometimes we're going to want to see all the little baby steps that happened along the way. Sometimes it's going to take a lot of small decay steps before you finally reach a stable isotope. So sometimes this is short, sometimes these can be quite long and complicated. The way this works is that your parent number 1 decays into your daughter product number 1. Then you take that daughter product and it's going to undergo its own decay in a second reaction. And now that daughter product has turned into a parent product or a parent isotope. It's going to decay into a new daughter product. Then that one is going to be the new parent, and now that one's going to decay. And it just keeps going and going as many times as necessary. So for example, here we have parent item number 1 decaying into daughter product number 1 and some radioactive particle. Now this daughter product is what we're going to start our next equation with. We call it a series because the product of one becomes the starting material for the next one, and it just keeps going and going and going. So we have a practice problem that looks like this. It looks a little bit crazy. We got all these weird circles and arrows, so let's take a look. What this is showing us is that uranium is going to undergo some kind of a decay and release a particle. And then this is the new daughter product that gets made. Then that daughter product becomes a parent. It undergoes its own decay, releases some kind of particle to make a new daughter product. Now that one becomes the parent. It releases some radioactive particle, becomes a new element, right? It's just kind of going and going and going. So what we're going to do is I'm going to do the first couple with you. I'm going to have you pause the video and try to finish it, and then we'll see how it went. Anywhere there's a circle, you should be filling something in. So up here, these would be radioactive particles. Down here, it would be the number of protons. This one right here, you got to figure out what symbol it would be, so on and so forth. Okay? So if I went from 92 down to 90 protons, and my mass went from 238 to 234, that's going to be an alpha particle, isn't it? For the next step, I went from 90 to 91, so I've gained a proton. Well, the way we gain a proton is by smashing up that neutron, creates a proton and a beta particle, and that beta particle gets released. You can see my mass doesn't change, right? So 0 was on the top, -1 on the bottom. Now I've gone from 91 to 92. Look, my atomic number went up again. My mass stayed the same. That is a beta particle. Now this uranium is going to turn into a thorium. Let's see. If I look at my periodic table, I'm going to be able to find out what that number is. That will help me figure out what my missing radioactive particle is. I went from 92 to 90. I went 234 to 230. That must have been a alpha particle. So why don't you pause, take a couple of minutes, maybe use pencil in case you got to fix anything, and you try to finish it up. All right, let's see how it went. Alpha. Then we're going to have another alpha. Another alpha. Well, now I went from 82 to 83, so that's going to be a beta particle. Well, uh-oh. This one's a little tricky. I have no idea what's here. So I'm going to have to try to skip ahead, and I'm going to have to try to figure out what this could possibly be so that in one more step I would end up with 210. So I'm going to figure out that this is 82. Well, let's see. If this is a beta particle, that would let this be 84. And then to go from 214 to 210 could be another alpha particle. So sometimes you kind of have to look and try to backtrack and figure out what your options would have been. Now to go from 82 to 83, that's another beta. 83 to 84 must have been another beta. Now to get from 210 to 206, that must have been an alpha. So what you can see is that we can have this whole series of things before we're finally at something more stable. So how would we graph this? Sometimes we like to look at this on graph paper because it's more obvious how far our atomic number is shrinking when we do it on graph paper. So you should have a piece of paper like this with the atomic number on the bottom, the atomic mass going up and down. What I'm going to do, because it's not going to fit nicely on my PowerPoint screen, is I'm just going to zoom in up here at the top part so that I can actually make everything big enough for you to see it. Okay? And then once again, I'm going to walk you through the first couple, and then you're going to finish graphing them. We're graphing the same problem we just did. So on your paper, you basically have all the answers. Now we're just trying to graph them. So let's zoom in and start up at the top. The way we do this is you're going to put the atomic symbol inside one of the squares. You're going to use this like a set of coordinate systems, right? So if we have uranium, 92, I'm going to be somewhere here, right? 92 protons is uranium. It told me it was isotope 238, so I'm going to be in this box up here. The problem you just did started with uranium 238 has 92 protons. Put your little symbol up in this box. Next, what we're going to do is we're going to put the new daughter product that we got in the box that it belongs in, which was atomic number 90, mass number 234. We draw an arrow between the boxes, and we label the arrow with which type of decay it was. These can get pretty squished. These can be a little bit messy. It's hard to get graph paper that's going to be big enough, so you can have all the space you want. I would use maybe different colors. That helps it stand out a little bit more. And then maybe use, pencil originally in case you make any mistakes. So let's do the next one. Next, we went from atomic number 90 to 91, but we kept the same mass number because it was a beta. And then I put the atomic symbol in the box. Next, I went to 92. I'm back to uranium, right? I did another beta and I'm back to uranium. But if you notice, look, instead of uranium 238 with all those all those neutrons, I'm now uranium 234. It took a couple of steps to get there, but I now have a lower proton to neutron ratio, don't I? So I've gotten more stable down here. So what I'd like you to do is keep going, okay? I'd like you to go all the way to the end. You should end with your lead 206. So you have a ways to go. So pause the video. Give it a try, and I will put the finished version up on the screen when you're ready. All right. Okay, here's my finished version. It's a photo of mine that I did by hand. It is a little bit small. I made it as big as I could, but it should be very obvious based on the shape if you got it correct or not. So we went from our uranium, we did alpha, beta, beta, back to a uranium. We did a whole bunch of alphas. Look how far down we got. Then we did a couple more betas. We did another alpha, couple more betas, and we did one more alpha. And we're down here at lead 206. This is a more stable isotope than what we started with. So if you want to double check and make sure everything's in the right place, you can pause the video and, go through it. Otherwise, if you're like, great, that looks good, I got my shape correct, I got it in the right boxes, I'm finished, then that's the end of the video for you, okay? So I hope that was helpful. Bye, everybody.